In this video, we're going to talk about tree diagrams and the fundamental counting principle. This is part of our pink unit, so we're going to go ahead and color pink. Alright, a tree diagram is a visual way for us to determine the sample space. Remember, the sample space is a list of all possible outcomes of an experiment. The fundamental counting principle states that the total number of outcomes for performing a series of experiments is equal to the product. Remember, product means times. And then, so it's equal to the product of the number of outcomes for each experiment individually. So for example, a coin is tossed 3 times, draw a tree diagram and list the sample space. Okay, so for my first coin, flip one coin and I can either get heads or tails. For my second coin, I can either get heads or tails. And then for the third coin, from each one of these, I've got 2 more branches and I can get either heads or tails, heads or tails, heads or tails, heads or tails. So that's my tree diagram. My sample space is where I just list the different combinations, and it's not really in this organized fashion. So I would follow each branch of the tree diagram. So the first branch would be heads, heads, heads. So I would write H, H, H. The next branch would be heads, heads, tails. So I would write H, H, T. The next branch would be heads, tails, heads. Heads, tails, tails. Okay, heads, yeah, heads, tails, tails. So then I follow this side, I would end up with tails, heads, heads, tails, heads, tails, 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 heads, and then tails, tails, tails. So again, tree diagram, sample space. How many possible outcomes are there? So I can count the number of outcomes from my sample space. I would have 1, 2, 3, 4, 5, 6, 7, 8. We can use the FCP or fundamental counting principle to verify. So the first example, for the first coin, there are 2 possible outcomes. The second time I flip the coin, there are 2 possible outcomes. And the third time I flip the coin, there are 2 possible outcomes. So 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. They match. What is the probability that 2 of the tosses will be heads? So I have to look at my sample space that I've listed, and I need to find all the ones where I have 2 heads. So if I do that, let me find a different color pen here really quickly. I've got 2 heads right here. I've got 2 heads right here. And I've got 2 heads right there. So the probability that I have flipped heads twice would be 1, 2, 3 out of 8. If I'm asked for that as a decimal, I would do 3 divided by 8. Divided by 8 is 0.375, and as a percent, that would be 37.5%. Right, what is the probability that at least 1 toss will be tails? At least 1 toss will be tails means that I have tails either once, twice, or 3 times. So it's at least 1 is tails. And again, I'm looking for a different color here. All right. So this one, heads, 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 that doesn't have any tails in it. Heads, heads, tails, that has 1. Heads, tails, heads, that has 1. Heads, tails, tails, that has 2, so that has at least 1. Tails, heads, heads has at least 1. Tails, heads, tails. Let's get 2. This one has 2, and this one has 3. So the probability that at least 1 toss will be tails is 1, 2, 3, 4, 5, 6, 7. So 7 out of 8 as a decimal is 0.875, and as a percent, that would be 87.5%. Alright, moving to the second page, we have a second example. It says a restaurant offers the following side options: fried pickles, mozzarella sticks, chicken wings, or vegetable of the day. For main course, the same restaurant offers a chicken salad, a hamburger, or a club sandwich. And for the dessert, they have cherry pie or chocolate cake. Use the fundamental counting principle to determine the number of meals they offer. Okay, so if I look at my first options, I have sides. And for sides, I'm given fried pickles, that's 1, mozzarella sticks is 2, chicken wings is 3, and vegetables are 4. So I have 4 options for sides. Okay, for the main course, I'm offering chicken salad, a hamburger, or a club sandwich. So that's 3 choices. And for dessert, I can have cherry pie or chocolate cake. So that's 2 choices. And again, I take the product of all of those numbers. So 4 times 3 is 12, times 2 is 24. So there should be 24 possible combinations. Okay. Draw a tree diagram and list the sample space. So starting with my sides, my choices are pickles, mozzarella sticks, chicken wings, or vegetable. And when I do a tree diagram, I try to pick unique letters. Okay? So it doesn't necessarily have to be the first letter, but something that will help jog your memory as to what it stands for. For the main course, we offer a chicken salad, a hamburger, or a club sandwich. So we have a chicken salad, a hamburger, or a club sandwich from each of these. Chicken salad, hamburger, club sandwich, chicken salad, hamburger, club sandwich, chicken salad, hamburger, or club sandwich. And then for dessert, they have cherry pie or chocolate cake. So cherry pie or chocolate cake. Pie, cake, pie, cake, pie, cake, pie, cake. And this process can be a little bit tedious. There we go. All right, so there's my tree diagram. And then for my sample space, again, I go through and I list all the different combinations. And again, make a list, not a diagram. So I start with my first branch. I have PCP, I have PCC, PHP, PHC, PSP, PSC, and then I'm on to the M. So I have MCP, MCC, MHP, MHC, and MSP, and MSC. Alright, on to the W's. I think I'm going to end up running out of space, so I'm going to kind of separate these two. Okay, on to the W's. I have WCP, WCC, I have WHP, and WHC, and I have WSP, and WSC. And then last but not least, I'm on to the V's. So I have VCP, VCC, VHP, VHC, VSP, and VSC. So my sample space, again, is just a list of all the initials, and then you have to go back and you have to remember what each one of those things stand for. So, question 1, what is the probability that someone will pick a chicken salad? So chicken salad, those were my main courses, and I used a C for those. So I'm looking for all instances where there's a C for chicken salad in the middle of my sample space. So I have PCP, that's 1. PCC, no, 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 no. Aha, there's another one, there's another one. No, 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 no. Yes, yes, no, 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 no. Yes, yes, no, 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 no. I count them up. 1, 2, 3, 4, 5, 6, 7, 8. Out of 24. Excuse me. 8 out of 24 possible outcomes. If I simplify that fraction, 8 out of 24 is 1 over 3. As a decimal, 0.333. And as a percent, that would be 33.3%. Okay. What is the probability that somebody won't pick chocolate cake? So chocolate cake was represented by a C in the third position. So I'm looking for everything that does not have a C in that third position. So I'm looking for, in other words, every place that there's a P for pie in the third spot. So this one, this one, this one, this one, this one, this one, that one, that one, that one, that one, and this one, and this one. So every place that there's a P. Again, if I look at this, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 24 possible, which reduces to 1/2 or simplifies to 1/2. 0.5 as the decimal, and 50% chance of choosing not chocolate cake. Last example, what is the probability somebody will pick cherry pie and fried pickles? So fried pickles were in the first spot, and I used P, and then cherry pie was P in the third spot. So I need to find all the instances where there's a P first and a P last. For example, this one right here. Oops, my pen is all messed up. There we go. So that guy right there has 2 P's. This guy right here has 2 P's. This guy here has 2 P's. And all the rest of them do not. So that would be 3 out of 24. Simplifies to 1 over 8 as a fraction. 1 over 8 as a decimal. 0.125. And as a percent, that would be 12.5%.